Okay, let's continue Chapter 8, hypothesis testing. So in this section, we're going to concentrate on how to perform the hypothesis testing, go over detailed procedure, to test the population mean view. Testing a claim about the population mean. And part 1 deals with the real realistic, commonly used case in which the population standard deviation is unknown. And that's so meaning you start with the sample. We can easily come up with a sample mean and then sample standard deviation. So you conduct a survey, a poll, collect the data, get a sample. From there, you calculate the sample mean and sample standard deviation. And then we go from there in terms of testing the claim. Part 2 discuss the procedure when sigma is known, which is very rare in real life. When sigma is unknown, we definitely use a t-test. And we call this incorporate student t-distribution. Okay, so it's serial t-distribution. It's very similar to the normal distribution, standard normal distribution, but with a standard deviation which is greater than 1. Okay, t equals 0, standard deviation is greater than 1. Okay. And here's a sample size. X bar represents sample mean. Mu of x bar, that's population mean. So the sample is simple random sample. Requirements to perform the hypothesis testing using a student t-distribution. Either both of these conditions satisfy either the population is normally distributed or the sample size is greater than 30. So test statistics, t equal to sample mean minus population mean divided by standard deviation, sample standard deviation over square root sample size. And p-values, we use technology, either Excel or any software, SPSS, R, SAS, either one of these works. We use the student t-distribution in table A3 with a degree of freedom n-1. We also have a critical value method using student t-distribution with a degree of freedom equal to n-1 together with alpha. Now let's review the student t-distribution. Important properties about the student t-distribution. Slightly different for different sample size. Okay, the sample size gets bigger, it gets closer, gets larger. The student t-distribution gets closer to standard normal distribution. So student t-distribution has the same general bell-shaped as a normal distribution. The wider shape reflects the greater variability, meaning population standard deviation is bigger, sigma is bigger. Standard deviation has mean of t equals 0. Same thing as z equals 0 with the normal distribution. Standard normal distribution. So standard deviation of student t-distribution varies with the sample size and is greater than 1. So let's take a look at example listed below as measure radiation emissions in watt per kilogram corresponding to sample of cell phones. Use a 0.05. This is confidence level. Now this is alpha, right? Confidence level is 95%. Confidence level that's why alpha equal to 0.05. significant to test the claim that cell phone has a mean radiation level that's less than 1.00. So summary statistics sample mean is equal to. So basically, you collect the data from 11 cell phones and come up with the radiation. We call that. So you sum up all these data values, divide by 11. So sample mean equal to summation of x over sample size, and that turned out to be 0.938. Okay, and the standard deviation, using the standard deviation formula, n times summation of x squared minus summation x squared divided by m times n minus 1, and that's approximately 0.423. Okay, this is exactly what you learned in chapter 3, how to calculate the mean and standard deviation. Now it's applied in this hypothesis testing. Now, first of all, we check the requirement. It's a simple random sample. So I think it's indicated question sample. Okay. The sample size is 11. It's not greater than 30, so we must check the normal quantile plot for normality. And if you look at the graph, it turned out to be like that. So let me just walk you through how to graph all of this in Excel. Okay. So first of all, you input all these data values into the Excel. Okay, let me just go back. So you input data values. That's exactly what we have on the question. So I'm going to label these x values. And let me format it a little bit. And once you have this, we'll be able to calculate the mean and the standard deviation and the sample mean. Sample mean is average, using the average formula. Highlight all those numbers. If you run it to, okay, missing a couple numbers. It's 11. Okay. Let's double check what's missing here. First one, let's do the data entry here. 0.38, 0.55, 1.5, 0.6, 0.92, 0.96, 0.086, 1.46 is missing here. Okay, now we have that. Now we can easily come up with the mean, sample mean. So average all these numbers. You get a sample mean. Running 3 decimal places should be exactly the same thing as what we have from the PowerPoint. Standard deviation. We do stdev.s. This means sample standard deviation. Add all those numbers. We have that. Okay, now you run it 3 decimal place. That should be exactly the same thing as you have on PowerPoint. Now, once we have this, we can calculate the z-score for each one of this. The normal quantile plot is based on the z-score. And let me just format it a little bit. So z-score for first data value is in cell number A2 minus sample mean. Again, we put $sign in front of each. We're using absolute reference, meaning every time if you want to calculate the z-score, Excel will go back to C13 for the sample mean. And dividing by sample standard deviation, again, we're going to put a absolute reference on a standard deviation. We get that. And again, you can drag it all the way down. Now Excel will follow the same formula for each one of this. Okay, you see the $sign absolute reference applied to all those mean and standard deviation. Okay, we get to the bottom of it. Now all you have to do is just plot this. Create a scatter plot of this. That's a normal quantile. So highlight X value z-score. Go to scatter to click on first scatter plot. And as you can see, it is followed straight line indicates, so it should be normal quantile. Normal quantile plot. And as soon as we see the straight line for all those z-scores, that indicates its normal distribution. Okay. And we see similar things from the PowerPoint. But this is the procedure to come up with a normal quantile plot. And let's go back to the PowerPoint. Now we know how this thing works now. So we get a sample mean, sample standard deviation, and we get a normal quantile plot. It looks similar to this straight line, so its data appear to be from a normally distributed population. Then we're using the student t-distribution. Now first of all, set up the claim. Now hypothesis, alternate hypothesis. Claim that alpha has a mean radiation less than indicates it must be an alternative hypothesis. There's no equal sign here. Alternative to our original claim is mu greater or equal to 1.00 watt per kilogram. You can also do mu equal to 1.00 watt per kilogram. Either way you want to set up a null hypothesis, it's good. So now I'm going to pick the second option, mu equal to 1.00 watts per kilogram. Okay. And set up a null and alternate hypothesis. And according to alternate hypothesis, this is left tail test. Meaning the critical region is located on the left tail. Okay. Now the stated level of significance alpha 0.05 because the claim is about the population mean mu. The statistics is most relevant to test sample mean x bar. Now sample mean on the question is 0.938. Population mean mu is 1.00. Sample standard deviation is 0.423. Sample size is 11. Now we're going to come up with a test statistics. This is test statistics. So plug the value into the formula. We get test statistics equal to negative 0.486. So in terms of t-score, you run it 3 decimal places to match the decimal places in the table A3. C score we run 2 decimal places, T score we run to 3 decimal places. Now we can use two methods. If you're using critical value method, then we have this. Now we need to find out the critical T score, T alpha. Okay, T alpha should be, see, alpha equal to 0.05, degree of freedom equals sample size minus 1, which is 11 minus 1, 10. According to those two, we go to table A3. On table A3, look for the corresponding critical T score. Area in one tail is 0.05, and then degree of freedom is 1 each 10, so we get an intercept. It turned out to be 1.812. So this is a positive one. So however, we're looking for negative one, so this should be reciprocal, so T score is negative 1.812. That's what we see here. Using the symmetrical positive one is 1.812 from table A3. So negative T alpha will be negative 1.812, which is on negative side. And again, we check this test statistics. T score is equal to negative 0.486. And again, falling the non-rejection region, it's on the bigger than that. So it's located on the right-hand side of the critical T score. So this is non-rejection region. So that means we fail to reject HO, fail to reject the null hypothesis. Using the critical value method. And then p-value method, you can use TI-8384. You can also use Excel to get that. So if you're using Excel, you're gonna, let me show you how to find this probability in Excel. So you're gonna do T.dist and put in the X value, negative 0.486, degree of freedom 10, calculated to be a true, and get this area which is 0.318, 0.319. That's what we have from the PowerPoint. So you can see 0.319. So we run it to 3 decimal places, we should get exactly the same thing. And this is what we do in order to find the probability using the formula in Excel. Okay. T.dist, T distribution, put in the T score, comma, degree of freedom. We accumulate everything to left. So get the probability turn out to be 0.319. And this probability is definitely is much bigger than alpha, so it's much more likely. That means we fail to reject HO. So p-value is much bigger than alpha, 0.05. Much more likely, so fail to reject HO. HO is null hypothesis. Because we failed to reject the null hypothesis, we conclude there is no sufficient evidence to support a claim that cell phone has a mean radiation level that's less than 1.00 watt per kilogram. And when sigma is known, we'll use a t-test. Standard normal distribution covers t-test. In reality, it's very rare to test a claim about the unknown population mean. when the population standard deviation was somehow known. Okay. Typically, if you know the population standard deviation, you know the population mean at the same time. But this procedure is essentially the same as the t-test, except we're using the test statistics. Slightly different. It's like central limit theorem. It's a formula for you to use for the central limit theorem. Sample mean minus population mean by population standard deviation over square of sample size. P-value we find it from the table A2. You can find Excel as well. Critical values we find using the standard normal distribution in table from table A2. Now let's repeat it. In this case, if you're assuming the standard deviation is 0.480, the test statistics will turn out to be negative 0.43. If you're using the p-value method, so z-score equal to negative 0.43. And then we can find the area to the left. So again, go to the table A2, look for the corresponding area to the left. Negative 0.43. And this probability turned out to be 0.3336. 3336. That's probability. You go back, then that probability is definitely much bigger than alpha. This area on the left is 0.3336. So the p-value is happening with a much higher probability. P-value is greater than alpha. So we fail to reject HO. Okay. It's a very similar conclusion. Since p-value is large, we fail to reject. Now hypothesis reached the same conclusion as before. Okay. So very similar procedure, just using different tables, Z table versus T table.